Well, welcome. I am Mr. Murphy, and in this particular video we're going to be looking at power standard skill number 2. And in this particular power standard we're going to be looking at how to determine the domain of a function when we're given a graph, basically. So let's look at an example of some problems that you'll be doing on your own here in a minute, and then we'll talk about some terminology that's going to be important for us to be able to achieve this particular skill. So for example, here's some that you're going to be working on in a minute, where they're going to give us a couple of graphs, and you're going to have to look at those graphs and determine what is the domain for those graphs. Well, it'd be helpful to know some, like I said, some details, some terminology first. So let's look at some terms. Now, if you watched the previous video, if you watched the video for skill 1, we would have looked at how to determine or what makes a function. So let's look at that again. So a function, remember, is where an equation, where for each input value, there results in exactly one unique output value. Now, when we look at an equation, like in the skill number 1, we're looking at values that we'd put in for x. Well, in this case, we're looking at a graph. And so we have something called the vertical line test. The vertical line test. And it's exactly what it sounds like. It's a test that we use, and the test that we use is we apply vertical lines to the graph. And if we have a situation where the line only intersects the graph at one point, then it is a function. So we can see that this graph here, it is a function, because no matter where you draw a vertical line, it only passes through the point, or passes through the graph at just one point. So now that we've established what a function is, let's look at how you would figure out what the domain is. So again, the domain, as we look here, is defined as the set of all possible input values, so the values that we'd plug in for x, which produce a valid output from a particular function. So what does that mean for a graph? So what that means for a graph is we look at the values for x that are graphed. So we look along the x-axis. We look to see, is there a limit on that? Is there a certain starting point and ending point, or does it go infinitely in both directions? And that's what's happening here. As you look at this graph, there's arrows at the ends of the line. So that's a hint that those lines continue in both directions. So as you look, if you follow along the x-axis, you can see that the graph continues to continues to go in the negative direction as we follow the x to the left. As we follow the x-axis to the left, to the right, we would see that the graph continues in that direction as well, infinitely. So it goes infinitely in the positive and negative directions. So we would say, in a situation like that, if it goes infinitely in the positive and the negative direction, we would say that our answer for the domain is that it's all real numbers. So how would we write that out? Well, we would do that by doing what we call set builder notation. So here you can see the same graph, and the way that we'd write that is using set builder notation, where we use those little brackets to identify a set. A domain we're getting from the value of our x's. So the way that we would phrase this is our domain is a set of all x's such that, that's what that little vertical line, remember, means. It means that phrase such that it's all real numbers. Now, what if there weren't arrows at the end of the line? What if there were just real bolded points, meaning that it didn't keep going in both directions, but it started and ended at those endpoints? Well, the way that we do that is like down here. If we have the far left, the x value on the far left starts at -5. And if we follow the axis along the right to get to the largest value, the highest value for x is going to be a +3. And make sure you're looking at the x-axis. We're not looking at the y-axis. We're looking at the x-axis. So the smallest value in that along the x-axis is -5. The largest value that's graphed on the x-axis is a +3. So if you write that using set builder notation, we would say that x goes from -5 to 3, or the way that we'd write that is -5 is less than or equal to x, which is less than or equal to 3. And it's less than or equal to because the points -5 and 3 are included on the graph. So let's look at some other ones. We're going to look at these two graphs together, and then I'm going to give you a couple that you saw at the very beginning of the video. I'm going to give you guys those to try on your own. So let's take a second and let's look at these two graphs and find the domain of these two and write the domain in set builder notation. Okay, so if we look at this first graph, this is what we call a sine wave, but it's got arrows on the end of it, meaning that it continues to go in both directions. In fact, it continues this pattern over and over and over again. So you can see that as we follow this graph along the x-axis, it continues to go in the negative direction, and as we follow this along the x-axis, we see it continues to go in the positive direction. So since it continues going in both directions, we would say that my domain here would be all real numbers. So we would say that it's a set of x's such that it's all real numbers. That would be your answer. Now let's look at the next one. The next one does not have arrows on the end of it. Now we can assume here that we're counting by ones. 1, 2, 3, 4, 5. Yep. So this point here, we look at that on our x-axis, and that would be where x is 1. And this point here, where the graph ends at, on our x-axis, is at 5. So we're graphing all the values for x go from 1 to 5. So here's how you write that. It would be the set of all x's such that, we start with the smallest number, 1, is less than or equal to x, which is less than or equal to 5. And that would be your domain. So why don't you guys take a minute and look to see if you can find the domain for these two graphs. So why don't you pause the video and hit play when you're ready to check to see if you have the correct answers. Okay, so on this first one, I can see, I'm going to assume that we're counting by ones here since they didn't give me anything different. So this is where our first value for x starts, is at negative 1, 2, 3, 4, 5, 6. So that's at negative 6. And here's where it ends, is at 1, 2, 3, 4, 5, positive 6. So the way that we'd write our domain, is it starts at, so it's a set of all x's, such that it starts at negative 6 and it ends at positive 6. So that's how you write your answer. And the next one has arrows on the ends of it, so as we trace the x-axis, you can see that it continues. I know it continues to go down, but you need to remember we're looking at the values for x. So we're looking across this way. The graph continues to get large. It's going to continue to going in the negative direction. And as we follow the x-axis going in the positive direction, you can see that it's a steep line, but it continues to get larger. It's going to continue to have larger values for x. So both in the positive and the negative direction along the x-axis. So all real numbers. So your domain, we'll write that like this. Oops. Well, there you have it. This is Power Standard Skill number 2. So hopefully you have a better understanding now of how to find the domain when you're given a graph and be able to write that domain in set builder notation. So with that, good luck now as you try some of these on your own.